Everyone, I want to welcome Dr. Parag Shankar Patil from IIT Gandhinagar. He has done his PhD in a very interesting topic, which is close to every one of us. Firstly, it involves the use of artificial intelligence and machine learning. But interestingly, he is applying it for the industrial problem. So let us hear it from him, what exactly his topic was, and so we will be discussing in very much detail, and also he will be telling us the secret to learn the artificial intelligence in an easy way and apply it on your particular industrial cases. So watch this video till end. We will also be talking about what are different kinds of job opportunities people may have, and yes, so let's start. Here we go, Parag. All stage is yours. Please let me know first of all about something about you, about your journey, and how it has been.
Okay. Okay. So first of all, thank you very much, Atharva, for having me here, because we were planning this since last maybe many months. First of all, thank you for that. Now, regarding my PhD or I shouldn't say a journey, because journey is a term for like really big people. But then for me, I did my bachelor's in petrochemical engineering from Dr. Babasaheb Ambedkar Technological University. After that, I did a job for 1 year, and then I joined PhD program in IIT Gandhinagar in chemical engineering. And then in chemical engineering, I particularly was working on a problem. Particularly, the problem was heat exchanger fouling, like how to basically understand fouling, and then mathematical models of heat exchanger networks. But the problem was mainly about the fouling of the heat exchangers, because fouling, although looks like a very small problem, but then fouling, if takes place in heat exchangers, then it affects the economy of the plant, and then right from the hydraulic.
Yeah. A tiny break. I will take it. So for our viewers, so fouling is basically the corroding of heat exchangers. So when different fluids flow through the heat exchangers, just like our pipes get corroded in our homes, the heat exchangers also does that, and it's a huge problem in the industry. It causes, I think, hundreds of crores of cost in the chemical industry.
Yes. In fact, one of the data points says that nearly 2 to 3% of the CO2 emission in the world is because of the fouling, particularly in the refineries. So although fouling looks like a very small problem, but then actually it has an anthropogenic CO2 emission, as well as, of course, like billions of dollars are spent every year in industries. That too, the number is accounted. Like for example, in the US and in the European refineries, or in the industries, the number is basically taken into account. On the other end, in the countries like ours, like we are kind of in developing stage, so we don't account for these numbers. But then still, if we take that into account, the number might be a huge number. So heat exchanger.
Okay. Yes, one thing I wanted to ask you here. So you are a petrochemical engineer, right?
Yes.
And you are interested in heat exchangers, but then I think you also studied artificial intelligence with that, right? So for many viewers who are actually watching the show right now, it's my curiosity as well, how I should start learning artificial intelligence. Simplest way, simple 2-3 points you want to tell.
Okay. So I wouldn't start from the equations and the things, but then first of all, we should understand that what is the motivation behind learning machine learning, for example, or artificial intelligence. Because nowadays we think that, okay, heat exchanger, let's say, if we'll just speak about heat exchangers, we know the shell and the tube side pressure drop equations. We know the heat transfer equations. Every one of us know logarithmic mean temperature difference, or P number of transfer units. So basically, what we understand is that okay, we know all the equations of the heat exchanger. Then why is it really necessary to do something more? Say, for example, machine learning. But then we should also understand that sometimes when this heat exchanger comes into interaction with other units in the industries, or let's say there is a distillation column, or there are other units which are very difficult to mathematically model. At the same time, when we do have a lot of data in the industry through sensors, say temperature sensor, pressure sensor, or the controller related data, the valve opening, etc. So if we have all this data which is coming out from the industry from a particular plant, then can we use it? Can we use it to understand the process better? So just this, if we will take as a motivation, this itself is kind of enough for us to start to understand or start to learn machine learning.
So basically, statistical analysis is what I guess is necessary to. That is the first step
Right,
to
right,
learn basically the principles of machine learning. First, one should know linear regressions, multilinear, multivariate regressions,
right.
and then we can build on that. And then finally, so are there any courses which are available? So just in
Yes.
one line.
Yes. There are many courses. So, for example, one of the popular courses is from Andrew Ng from Stanford University, and he has this course of basic machine learning and advanced machine learning on Coursera. So that is one of the nice courses.
Okay. And also to the viewers, you can go to Swayam website on, so that is by Government of India, and all the courses in machine learning, then artificial intelligence, it is available for free on that. And they are really good courses. Even I have also done a couple of courses, and the knowledge which is imparted is very, very rigorous in that. So please go and check it. I will be also sharing the link in the descriptions. So please check that. Okay. So this part, then the next part I wanted to ask, out of again my curiosity. Now see, say I know machine learning, I know artificial intelligence, and now I am a chemical engineer. Forget about other processes. We'll take a very simple example of heat exchanger. Now I know heat exchanger, and I know machine learning. Say, so what should be my strategy to apply machine learning on heat exchanger, and what should be those first steps to for the application of artificial intelligence on heat exchangers?
Okay. So let us assume just a standalone heat exchanger, for example, like forget about networks and all. Even if we will take a standalone network, then we can actually do some prediction. For example, let's say we just so there is one way, right? We can have inlet temperatures and the flow rates, and we can and one of the outlet temperatures as well, and then we can calculate mathematically the outlet temperature of one of the streams, because that is the usual way, right? Because we know the equations and all. On the other hand, we can also imagine a situation where that model is unknown. For example, let us imagine that this logarithmic mean temperature difference, or Q is equals to UA LMTD, that equation is not known to us. So what we can do is actually we can have, say, for example, a simple neural network, and we can take this all the inputs that we usually give to our mathematical model, say the two inlet temperatures, one outlet temperature, and then the say heat, like area, for example, all the information that we know, and imagine that this information is coming from say, for example, a plant. So therefore we will also have the time series of this data. We will not just have one temperature inlet, but then multiple time stamps of this temperature, and then we can take this data, and we can so as a first instance, since we will also have all the data, say for example, all the output temperature, all the input temperatures, etc. With the help of this data, we can actually train a simple model, and then we will understand based on the techniques in the machine learning that okay, the model is sufficiently trained. Now what we can do is we can now use all the temperatures except one temperature outlet, and then uh, we will try to estimate that one outlet temperature from our all the measurements, and then we will also try to see whether the measured temperature from the plant and the estimated temperature that we have just estimated using, say for example, neural network or any machine learning method, and then we can see whether that temperature matches with our estimated temperature or no. This is a simple example which we can do.
So I will just break it down. So see,
Yes.
now I have two boxes. One box is machine learning, and one is my heat exchanger.
Right.
Now I want to join these two boxes with a wire. Say this is the data transfer. So
Right.
on on my heat exchanger box, I have a sensor which is going to calculate, which is going to send the data for temperature. Is it right?
Right.
Inlet and outlet
Right.
temperature.
Right. Yes.
So this is, so at different times, what kind of temperature changes are happening? This data is being sent back to the
Right.
my machine learning box where artificial
Right.
intelligence is happening. And this particular data is now being processed by my artificial intelligence to predict what exactly. That I wanted to understand.
Okay. So for example, in this example, let's say we do not know one. Let us revise example a little bit so that it will be very easy. Let us imagine a heat exchanger where tube side inlet and the outlet temperatures are known, right? Shell side inlet temperature is known, but outlet temperature is not known. Let's say the temperature sensor is like damaged. We do not know. But then, but the flow rates are known, let's say. So in our case, we do not know shell side outlet temperature. So what we can do is, one is like mathematical modeling. We will solve this Q is equals to UA LMTD. Sorry, heat transfer on both of the sides, like shell side heat transfer rate and the tube side heat transfer rate. We will match it and we will find the tube side out the shell side outlet temperature, which was unknown. That is our usual conventional way. So what I'm trying to tell you is now how to use machine learning here, just as an example. So first step, what we will do is we will take all this data from the industry except one temperature which is not known, and we will estimate this with our equation. So right now, so after estimating, what we will have all the data which is there available in the industry, and one temperature sensor's outlet temperature, which we have calculated, say for example 100 hours. So what we will do is we will take 50 hours of this data. We will train our heat exchanger model. We will say that, imagine, let us say that if you have this flow rates, if you have this inlet temperatures, and if you have this tube side outlet temperature, you should have shell side outlet temperature is equals to 100 degrees Celsius for 50 steps, because we have anyways calculated it from our model. Now what we will do, we will train. So this phase is known as training. Like we will train our heat exchanger model every time, that when this will be the data, your shell side outlet temperature should be this much. Now what we will do, in the next remaining 50 hours, we will remove that shell side outlet temperature. We will say that, okay, now it is your turn. We will ask machine learning model that it is your turn now. Now imagine, now this is your input data. Tell me what is the shell side outlet temperature. So if that model would be trained in a better way, then that shell side outlet temperature will match to our actual shell side outlet temperature. So just to add one point, in a conventional way in machine learning field right now, we call something as digital twin of the process. So what I told you in very crude or in very rough way is the digital twin of this heat exchanger. So this is nothing but a digital twin of heat exchanger. Okay, so this was the answer to your question.
And now, what kind of a models generally are used to?
Okay.
What is that by default models in machine learning, which you can recommend?
In machine learning, basically there are two types of models. One is supervised kind of models, and the other ones are unsupervised models. So let me give you a very easy to understand example. Say, let us say that we know. So, for example, the example that we just saw, that we were knowing all the measurements for a heat exchanger, but we didn't know the outlet temperature of shell side. But then our model was going to help us to estimate that outlet temperature, or to predict that outlet temperature.
So say now I am a chemical engineer, but moving ahead, I want to explore the artificial intelligence and the application of that in the chemical industry or in a process industry, any industry. So I want to understand what will be the right way to pursue this career. How I can convert my profession, which is a conventional engineering profession, into a artificial intelligence based application, so that my value increases. So basically, why I'm asking you this is So carrier may become stagnant at one point of time, but you want to add it up with some skill, which is a new generation skill. So give us a roadmap on how I can start learning artificial intelligence and start making my case studies, or
Okay.
make my portfolio as per that.
Okay. Okay. So, okay, this is a really nice question, because based on this question, I can actually tell you, first of all, even before this question, to answer this question, why we, or generally why people use machine learning in process industries, for example. So in process industries, there are many things which we can do with the help of machine learning, and people generally do it. For example, imagine that there is a stream in a process, like there is a stream in between, which is drawing some product from a distillation column, right? And we do not know the temperature on that particular stream. So in some settings, what people do is that they develop soft sensors. They call it soft sensors. So what do you mean by soft sensors? Soft sensor is a virtual sensor that they develop using just machine learning algorithms. So that is kind of an example. Another is kind of the predictive maintenance algorithm. So, for example, in heat exchangers, we know that after some time, because of fouling, the heat exchangers need to be cleaned. But when to clean those heat exchangers? How much fouling is going to be there in future after a while or so? So such kinds of problem, like this is not just a heat exchanger problem, but imagine a compressor. So in case of heat exchangers, or in case of the distillation columns or the process industrial like units, we can take temperatures and the pressures and the flow rates. In case of these rotating equipments like compressors, we can actually use their vibrational frequencies, etc., to train our models and to identify when to do some maintenance for this such types of units before they actually fail. So there are many kinds of problem which people do, that is very difficult to do with the help of the conventional mathematical modeling approach. So coming to your question, that how can we do our case studies, right? How do we do some case studies to understand, uh, uh, or to develop some case studies for ourselves, so that we will be learning machine learning to implement it in kind of real scenarios. So I can tell you, say for example, just one example. We can have the distillation columns in our. We can develop our own distillation columns basically in Aspen Plus, or we can just write our own equations and we can do those models. Then we will have those data. For example, the input data and the output data, the temperatures and the pressures and the flow rates. And now we can do some some things which we will be able to also replicate with machine learning. For example, fault detection. So imagine a scenario where this distillation, the top the top where the condenser sits in the distillation column is not working well. So we will have to tweak our Aspen Plus or the mathematical models to generate that fault in our simulation. Then we will have and imagine a situation where you have already generated that fault. So now what we will have, you will have a data set of the input and output, everything without fault. Then you will have another set of data with fault. Then you can have actually multiple faults uh, that you have to generate in Aspen Plus using some of your process understanding. So now what you can do is you can do you can use machine learning to classify a fault. So imagine now there is this distillation column actually which is working in industry. Now you can have your machine learning model as a digital twin of this distillation column, and you can see, okay, if this outputs the temperatures and the flow rate, the temperatures in particular, or the pressure drops, etc. Which is the class, which of this faulty class where this the current outputs are matching to a very good extent, and then we can actually classify that, okay, since the observation lies near to this fault number one, then we can actually say that, okay, there is a chance that this distillation column has kind of like fault one. So there are many such small examples that we can do to learn ourselves.
So basically, we can use Aspen Plus or some software which we already know, and then we generate two sets of data. One is where we know that everything is running well and good, ideally, and second is we can actually induce the faults and then
Right.
generate the bad data, and then we
Right.
input this to train our algorithm, so that
Yes.
our algorithm knows that this is the real data which I should have, and if I'm not seeing this, then classify what can be the fault, and that's
Right.
how our algorithm will actually predict that what can be the fault and where you can go and look for that fault in what part of the distillation column. Yeah. So
Right.
yes, so this algorithm I understood now, but also let me know one thing. See, now where, I mean, what should be the programming language?
Okay.
We need to also have a structured way of executing this exercise. So what can be that structured way you feel that how, say, once the data is generated, right,
Hmm.
using Aspen, what I should do with this data?
Okay. So actually, there are now many programming languages. For example, generally people use Python. So in Python, there are many packages. So first of all, if somebody wants to understand and somebody wants to use it, then there are many packages in Python, or libraries in Python. Those can be used. For example, like I would like to name a few. For example, there are scikit-learn. But apart from that, one should also learn pandas and numpy. So these are some of the libraries one should learn. And then if you learn these libraries, I mean, you need not to learn these libraries. But then if we know how to use these libraries in Python, then there are some functions in the. So I would like to make it very simple, so that it will be like very easy to understand. So in these libraries which are there in Python already, we can actually like we can formulate our problem in a way that we can solve it. For example, if I want to use neural network, then scikit-learn will have a function called neural network, where we can actually we can classify, we can give the data to that particular methodology, or the library or the function of the neural network, that okay, take this data, segregate this data into two half. Like one is like training data, and the other one is to test. So basically, one, I think, like to me, one should easily uh, one should learn Python, and then one should also know how to use these libraries or the packages in Python, and then it will be like very like kind of easy to execute this machine learning methods.
Yeah. So I think that is the roadmap which I can see now. That if you know the chemical engineering, if you know heat exchangers, for example, and you may want to learn some part of artificial intelligence, machine learning, some tools starting from statistical analysis and going towards forming the algorithms in machine learning, random forest and tree algorithms. This all data
Right.
is basically available on the NPTEL right now. You
Right.
can just search these keywords, and there are very good lectures, free of cost lectures are available. And once you are done with this, then you just need a Aspen Plus or a trial version of Aspen where you will simulate, or even you can do a DWSIM as well. DWSIM
Right.
maybe
Yes.
can be useful to generate this
Mm.
data, and just switch this data into the algorithm which you learned and try to implement it. If you can see, if it is predicting certain results for you, I think that is the roadmap which we can tell to our viewers, that this can be 1, 2, 3, 4, 5 points where you can actually transfer from a conventional chemical engineer or a conventional process engineer towards the new generation artificial intelligence I think I should say thanks to Parag. He really we were actually hoping to get this done a few months back, but due to some of the engagements which me and Parag were having, we were not able to accomplish this. So this is it for first part. I will say I will definitely want people to comment and like, share the video, and also to suggest whether you want something in detail. What I would like next maybe is if we can actually discuss neural networks in details with
Right.
the with the hands-on, something hands-on on I think that can be the way to move forward.
Yes, 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 yes. Yes, sometimes I think that sometimes it is very difficult to explain because
Huh,
because as an engineer I am not used to very much to like teaching kind of sessions. But then of course if there would be an example which we can do together, then that will be better.
definitely,
Yes,
definitely.
yes, yes,
So
yes.
let's move on the next part. We will stop for now here, and please
Thank you very
do
much.
like, subscribe. Also, Parag also runs a very good channel where he explains all the S10 plus processes, the mechanisms, how to use. So please explore. I will be sharing the link in the comments and in description. You can definitely go and check there. Yeah. Thank you. Thank you very much.